Hello everyone. Hope you guys are doing well. Hope your exams are going well, and your preparation for physics is also going pretty well. Uh, so today we are going forward with our kinetic theory of gases, and there are a few terms which we are going to utilize going down the chapter. So we are just going to discuss those terms today. So it would be a very short video today. Before we start, if you haven't subscribe my channel. Please subscribe the channel so that you can just get future updates. So the first term today we are going to understand is called as the mean free path. Now I just keep on focusing on the laser. Let's say we have a molecule A, and this molecule A has a motion in this particular direction in which the laser has been pointed. Now this molecule A goes and strikes molecule B, and B might go somewhere, but A just moves on to hit C. So A is moving on to hit C, and C may go somewhere else, and A turns back towards D, so it went to D. Now while A hits D, D might go somewhere else, but A is going to hit some other molecules. So basically this the entire track of molecule A. Now between molecule A and molecule B, this distance is called as the free path. Why is this called as a free path? Because this distance is the distance in which there was no collision. That's why it was a collision free path. Same way, when the molecule A went from B to C, this distance was free of collision. So the distance traveled by a molecule which is free of collision is called as a free path, this is called as a free path. And we everybody understand what mean is. Mean is basically taking an average. So the average of all such distances is what is called as the mean free path. So the definition is in front of you. The average of the distance traveled between collisions is called as the mean free path. So average of distance traveled between collisions is called as mean free path. And the formula for mean free path is pretty simple. Now the free path is written as lambda. So if the first collision is 1, lambda 1, lambda 2, lambda 3, then the mean, that is the lambda mean, that is the mean free path, is just the addition of all the distances which are free of collisions and divided by the number of collisions. Now I would just like to make a point that this n is the number of collisions, and this is all about mean free path. Now let's go to another term, and another term is called as the average velocity or the mean velocity. Now average or mean, it's just a statistical word, and it bears the same meaning what it has at every other places. It's just the addition of all the terms and division by the number of quantities. So the average of velocities of all molecules. So in a container, the gases might be having molecules, and molecules might be moving with some velocities. Some might be moving faster, some might be moving slower. So if you add the velocities of each molecules and divide it by the number of molecules, what we get is called as the average velocity. So average velocity is nothing but just summing of all the velocities of molecules divided by the number of molecules. So this is what I was trying to highlight. This is the number of molecules. However, when we were doing about mean free path, it was n was the number of collisions, and this is number of molecules. So C1 is the velocity of the first molecule, C2 is the velocity of the second molecule, and Cn is the velocity of the nth molecule. So you just add them up and divide by the number of molecules. Then we come to the next term, which is called as the mean square velocity. Now the average of, now before we go to the definition, what happens is, why we find out mean square velocities? Because when you find out mean velocities, or mean of or an average of something, and if the velocities, if the data goes into negative, like if the data is positive as well as negative, then there is a chance that the average velocity can come out to be zero. But as we have understood in the assumptions of kinetic theory of gases, that molecules are in a random motion, so the average never can come out to zero. So what we do is we find out mean square velocity. Now even if the velocity of the first molecule is minus, but a square of a negative number is will always be a plus number. So this number will always come to be as plus, and so will the other numbers as well. So your c square bar, that is the mean square velocity, can never go to 0. Now, so what is the difference between a mean square velocity and a mean velocity? Is the difference is just that you need to square each velocities before you add them. Square each velocity before you add them. So c1 square plus c2 square until cn square, and divided by this n. This n is again the same thing. N is just a number of molecules. Now this mean square velocity is written as c square bar. Now just make sure that c square bar and c bar square, these two are different quantities. This is like mean square velocity, like you just have to square them first and then take the average, and this means that you take an average and then you square it. These two are not equal. Just make sure that these two may not be equal. Okay, so just make sure that while you are writing mean square velocity, you need to write the square and then you should write the bar. Now let's go to something called as root mean square velocity. Now this is where we are going to need this root mean square velocity. Now when you take an average, basically the velocities come in between the maximum and minimum reading. Like suppose if you have readings like 5, 3, maybe 2, maybe 7, maybe 6. These are the velocities. Like this is your c1, this is your c2, c3, c4 and c5. Now when you take an average, C average, the value would come somewhere in the middle of 7 and 2, because 2 is the minimum reading and maximum reading is 7. That is okay, but when you have negative values, because velocities can be negative if they are going in the opposite direction, then the average can come out to 0. That's the reason why we find out the mean square velocity. But when you find out mean square velocity, there is a chance that you might get an answer which is not in between 2 and 7, because you are just squaring those terms. You are just squaring those terms, and squaring will increase the numerator, and so will the mean square velocity may come outside the minimum and maximum value. But no molecules is moving with a velocity greater than the maximum value. So what we do is we take the square root of the mean square velocity. So when you take the square root of mean square velocity, what you get is root mean square velocity. Root mean square velocity. So that's what the next topic is. So root mean square velocity, the square root of mean square velocity is called as root mean square velocity, and it is famously written as RMS. So CRMS is equal to square root of the mean square velocity, and if I put this value as c1 square plus c2 square plus c3 square, it is cn square divided by n. This gives us the formula for RMS velocity. So these are the 4 terms which we'll be needing while we go ahead with kinetic theory of gases. So make sure that you learn these definitions and the technicalities behind that. We'll wind up for today. This is a small video, but definitely in the coming lectures we'll be going deeply into kinetic theory derivations. And just make sure that you copy all, or just take the screenshots of all the definitions and formulas which you might require while going while solving some numericals, average velocity and then mean free path. Okay, so in case you haven't subscribed it, please go and subscribe and hit the bell icon. um, Thank you so much. Bye.